Okay, in this lesson now, we are going to see how we differentiate irrational functions like root x and 1 over root x. That's what we're going to cover in this lesson. We have seen how we use the function notation. Now in this lesson, I'm going to focus so much on the small changes. Please don't forget to subscribe to the channel. Okay, start with differentiate the following from first principles. We need the difference of two squares. If we have a minus b, a plus b, so this is going to be our difference of the squares. I know that whenever we have a root, it's the same as a half. So root x is the same as x power half. And then we shade this. Okay, now the idea of this is when we push a function, the negative power, its sign is going to change of the power. The positive root x is the same as x power half. So the idea of pushing this to the denominator, you're also going to apply it here. So let us handle this. What we say, now let y be root x and delta y, comma, delta x be small changes in x and y, in y and x respectively. Now after doing that, see that now I had my y equal to root x. Then if I receive a small change in the x, also y is going to receive a small change. So delta y is going to be root x plus delta xy, because it's that y is variable in x. So any change in x leads to a change in y, or any change in y leads to a change in x. That's why this one receives a small change, even y will receive a small change. Now from here, what we do, we make delta y a subject. We take this side. So now then minus ry. But remember, ry from here is this. So my delta y will be root of, then minus root of x from here. I think you can see that. Now from here, what we do, we are going to create a difference of the squares. How are we going to do this? Look at this. So my delta y. Now create a difference of the squares. This is a difference of the squares. What I have in this bracket, I need this one. What I'm going to do, I'm going to get the same thing and the same thing. Then I multiply it here, but when the sign is positive. What we have is a negative, we are missing this. So I'm going to create it up and down. So you create, but because it wasn't there, we remove it. So look at this. I have root delta x minus root x. Now to create it, in simple terms, we create a positive sign in between. Now plus root x. Then we multiply this thing also down to remove it because it was not there. So I think you see it. I've created it and I've removed it. My idea is to create a difference of the square. I want to make this the same, this the same. My difference is going to be in the sides. So from there, my delta y will be now. If I have this now, you can see that I have this, I have this, I have this, I have this. The difference is in the side. It becomes a difference of the squares. What we do, we get a bracket with the minus, we square the first term. We maintain the negative, we square the second term. So now I get this bracket, I square the first term, then minus, I square the second term. So the whole of this is in there. Remember, we are adding root of x, then plus root x. And this is our members. If we expand here, we shall have this square will go delta x, then minus x, the whole over root x. Understand this and this, this and this they vanish. So I remain with delta y equaling to delta x over root Now what I'm going to do, if I divide this side by delta x. So I divide this side by delta x, 5 multiplied with 1 over delta x. So delta 1 over delta x is going to be, that means 1 over root of x plus delta x plus root x. What I do, I'm dividing this side. Divide this side, divide by delta x here, divide by delta x there. Oh, what I've done is delta x will be equal to delta x over delta x, the whole over root, then plus root x. That's what I have done to get this. Now we note that as delta x tends to 0, then our limit, when we put this limit in delta y, delta x, is going to give us a full derivative. These are partial derivatives. So now it means that where there is delta x in this function, this is our function, I'm going to put delta x as 0. So here, I'm going to put 0. Then when I put it as 0, it means that all of this will be now the y dx. Now, it means that after putting the 0 in this function, it becomes the y dx. So look at this. So now I'm going to take from here. So the limit as delta x tends to 0 is going to be the limit as delta x tends to 0 of which function? I'm introducing limit this side and this side at this step. 1 over plus root x. So now I'm saying this one is going to give us this. This will be the y dx equal to. Now I'm going to put a 0 where it is delta x. This will be root x plus 0 plus root x, which will be 1 over root x plus root x. Or 0 plus this, you get root x. And so if we add this and this, you see that this one will give us 1 over 2 root x. This root x plus root x will get to root x. And now, mind the x. At this step, you always remove your y because it wasn't in the question, as you see. So my y was root x, now equaling to 1 over 2 root x. So that becomes our answer. I think we see that's what we have to get. Now we handle this one to the same idea. So number 2, 1 over root x. The same idea, we select y, be 1 over root x. Means that now, from here, this receives a small change. So my y plus delta y will be 1 over root. Now also x receives a small change. The small change is received on these variables on y and on x like that. Now, I'm going to take y, the other side. So now my delta y will be 1 over root x plus delta x, then minus a y. From here, when I take this side, I know my y is this. Now it's that my delta y will be 1 over root x plus delta x, then minus my y, which is 1 over root x. So from here, allow me, we are going to cross multiply. Cross multiply up and down. So r delta y is going to be this times this times this. The whole over. Now when I multiply this, I get a root x delta x and times a root x. Okay, so from there, when we come to this, we also going to create a difference of the squares up and down. So now, from here, now multiply it up and down. So my delta y will be root x minus root. Now I multiply this up and down from here. Now the same thing, this we created here. So I'm going to write this here. So I'm going to be adding root x. Now with a positive. Then nothing over. Remember, when we have to multiply each other, this one multiplies this. So this will be now root. This times this x squared delta. X times delta x. Get x delta x. Now over root x plus delta x. So we have created this up and down. The simple terms it's not there because it's this and this there because we are just creating it. Now from there, so our delta y will be root x whole square. Now we are creating the difference of the squares here. Then minus. You see this is the same. The difference is in the sign. So they are creating the difference of the squares. Get a bracket with the minus, square the first term. Also square this last term here. Whole square. The whole thing down here. We are having now this times this root of x squared delta x. Now multiplying this root delta x. Now is that if we square our is going to be now with x minus. Now remember this minus. Okay, let me not skip that step. And the square this goes away. Now over root x squared delta x into now root x plus root x plus delta x. Now, you see when I open the brackets, this is going to be minus x and this is going to be minus y. So delta x is going to be, delta y, x minus x goes to 0, then this negative and this, I get negative delta x. The whole thing over. Remember, I'm dividing with root x squared plus x delta x into root x plus root x plus delta x. The whole of this is dividing that. Now, if I divide this both sides, you are going to allow me to use this part here. I'm going to use this part here. So I'll be having delta y, delta x equal to 2. Now you see I'm going to be adding a negative 1 up over now root x squared plus x delta x multiplying with root x plus root x plus delta x. Now here I say as delta x tends to 0, now the limit in delta y, delta x, when delta x tends to 0, is going to be giving me the y dx. Means that now, where is delta x? If I substitute there 0, I'm going to be having a full derivative there, right? This step here. Now I do y, x is going to be now negative 1 over. Now where is delta x? The substitute as 0. So I have now root x squared plus x times 0 times this 0. Then into root x plus root x plus as 0. Like that. So now I do y. X will be negative 1 over 0 times this is 0. Have now root x squared times root x plus root x. This will give us negative 1 over x into 2 root x. Square root of x squared is x. Then add this plus this, we get 2 root x. Root x plus root x, we get root x. Now, this will be negative 1 over x, but remember, as 2 is the same as x power half. We say the root is the same as this. Remember, the same numbers of the same persons shall add the powers. This will be negative 1 over 2x, 1 plus half. So from here, now our d, 1 over root x. The x is going to be negative 1 over 2, now x power 3 over 2, or this can be negative 1 over 2 root x, the whole power 3. That's how we get to that. So yeah, that is why our line from here was that. So members, that's how we handle that. We see you.